I'm a professor of civil and mineral engineering at the University of Toronto. So particles, and part of the reason I like to study them, is particles come from both the inside and the outside. In the outside, it might be from traffic or from some combustion process going on outside. Inside, there's a whole host of sources. Our activities like cooking, smoking, maybe walking even along the floor stirs up particles. And so part of the reason why I like to study particles is there are so many different kinds of particles coming from so many different places. In terms of how we control them, we have three main tools in our toolbox. We can do source control, which means trying to get rid of the source, not always possible. Then we can use ventilation. Of course, ventilation requires that there not be particles outside or that you filter them so that you're not just adding more particles to the space. And then our third approach is filtration, like the filters that are studied in this lab, where we essentially strain the air to remove particles. We have seen a revolution in things to measure particles in the past decade or so. So it used to be that aerosol instruments were all very, very expensive. You could spend tens of thousands of euros or more to measure particles. These days we have a lot of low-cost sensors, and a low-cost sensor usually uses a laser or some other optical means to assess what's in indoor air. Now, so those are our main tools, everything from very expensive to very cheap sensors. The whole thing about measurement in indoor air, be it in an HVAC system or in any environment, is that how you do the measurement is as important as the measurement itself. So there is no good or bad sensors, there is only using a sensor well. The indoor measurement is really important, but what everyone needs to understand is we measure what's typically easy to measure. And so the two things you measured, carbon dioxide, there are many relatively low-cost sensors for carbon dioxide. Particles, there's increasingly low-cost sensors for particle measurement. So those are two very important things to measure because they're related to sources, the performance of ventilation, other things we might care about. However, there's many other things too that we would also like to measure. In many environments, we'd like to measure formaldehyde. We might like to measure a specific volatile organic compound, and we very rarely have sensors to do that. So I kind of see as we build a foundation of what's easy to measure, and then as needed, we might bring in more expensive instruments and hopefully develop technologies to measure other things that might be of interest. Okay, so I think I did more interviews for the media and for the general public about filtration and ventilation in the first 6 months of the pandemic than I had done in the 20 years of my career prior to that. So there's a ton of interest. And that's continued to a certain extent, but I also sense it might be relaxing a little bit as we move into later stages or past the pandemic. And I think that one of the critical challenges for people like me who study indoor air is how do we keep people engaged? And so, I talked with a lot of politicians and policymakers and public health professionals during COVID, and there are many fewer of those conversations now. And so we have to think about how we take the lessons of the past few years and translate them into permanent policy. And that's a really interesting question, something I'm very engaged in, but I don't think it's an easy question because, all of our politicians, all of the public have many, many concerns. And as the pandemic recedes into the past, we start seeing issues like economics becoming very, very important or something else displacing what we used to do thinking about COVID-19. So we saw some motion about measuring indoor air throughout the pandemic, and that has stuck in a few contexts, but it hasn't really stuck on a broad scale, at least in North America, where I'm used to things. And so I think that one of the big challenges is that it's very hard to have indoor standards for air quality because people feel very personal and private about their indoor spaces. And so it's not like an outdoor space where there are a lot of individuals contributing to an outdoor concentration measurement, so it's politically easier to have a solution. And so what I hope we see is continued attention in the continued use of measurement to improve indoor air. I still think we're a long way from using measurement as a general tool. So one of the things I love about what I do is that every building is a puzzle. There's no one answer, right? We use the same basic tools: source control, ventilation, and air cleaning and filtration. But how we apply those is very, very context specific. So, you take a building archetype like a school. A very new modern school with mechanical ventilation is going to require something very different than a school that's 150 years old, maybe with windows that don't open very well and all kinds of other things we see. It matters whether that school is located in a cold climate or a hot climate. And so part of the beauty or the fun of what we do is we look at each building and say, how can we apply the basic principles to address the specific indoor air quality in the space? So I always think back to the indoor air quality course that I teach. And it's a civil engineering course. I get, in a typical class, maybe 50 or 60% of the students are from civil engineering, and the rest are from mechanical engineering, chemical engineering, public health, architecture, other disciplines. And I think that's really what highlights the importance here, is that aerosols are in fact ubiquitous, right? There's in all types of engineering systems, there's aerosols. They're important in things like combustion systems, obviously, but they're also very important to our health. And so you get a lot of health and exposure related disciplines where they're important too. Not to mention, aerosols are used in a variety of chemical and other manufacturing industrial processes. And so why a lot of students appreciate the aerosol aspects of the courses I teach is because there's always a hook to something, even if they don't study indoor air or don't study aerosols specifically, the basic principles of the physics, the chemistry of what goes on applies to a system that they are interested in. So the short answer is the university is a big place, so I'll talk about myself. I collaborate extensively with people all over the world, including in Europe. And I think that the collaboration is really important because there is this really important contextual issue. The air quality in the room I'm in right now is different from the air quality in my office in Toronto. And so through those collaborations, we bring those different perspectives, those different contexts together. But then there's also different technical expertise. And so different educational systems have different emphases and bring different fundamental issues together. And so at any given time, it kind of depends how you define a collaboration, but I like to have active collaborations with many different groups all over the world, as well as all over my own university, people from other disciplines. Yeah, so aerosol science is important, of course, if you're going to be studying aerosols. But again, I think that the real value of an aerosol science component to one's education is you're bringing together a whole bunch of different factors together. So the particles in the air in this room right now, they're affected by so many different things. They're affected by the airflows. They're affected by the electrical charge that's on them. They're affected by thermal conditions. They're affected by how much is coming in from ventilation, a whole host of factors. And so the real value of aerosol science is bringing those disparate pieces together. It's inherently a complex system, but it's also a tractable system, one you can understand and you can measure, so you can draw parallels. So I think that's the real value, is seeing how these pieces fit together. I also think that there is a very important practical issue. For those who study outdoor air quality, indoor air quality, buildings in general, we know that particles are very important to our health. There can be specific health outcomes, like we just saw with the COVID-19 pandemic, but there are also a variety of long-term chronic health outcomes that come from breathing particles. And so I believe you cannot have a healthy building unless you address aerosols and particles in the building. And so you asked about engineers and architects. I think that there is many other disciplines as well that benefit from aerosol science. And I think that's where we need to think about going as a profession, is how do we engage people who do infection control in hospitals, people who study how students learn in schools. There needs to be a component of aerosol science there.